Hello world! Welcome to Learning Java, one byte at a time. This is video 34 in a tutorial series geared at bringing the wonderful wide world of Java to those with little or no programming experience. This video is a continuation of the development of the Booker application, a vehicle appraisal app. In the last video, we successfully performed unit testing on the parse advertisement method of the populate advertisement class to see if it was able to successfully accept an advertisement template, a vehicle object, and a final appraisal price and dynamically generate a sales ad for us. And it seems like everything's working correctly, so now we can begin to work on the final feature of this application, which is the Bluebook class. And the Bluebook class is going to accept some vehicle object and some base price, and then it's going to in turn call an instance of another class called price adjuster, and one at a time pass through all of the attributes of the vehicle. The price adjuster is going to make some subtle adjustments to the price, as the name would imply, based on some sort of basic arithmetic. And then the Bluebook class is going to accumulate all of those adjustments and return the final appraisal price, which is going to be the value that we pass through to the parse advertisement class, or the parse advertisement method. And so this is not overly complicated math, but it is a little lengthy because our vehicle does have quite a few attributes, so this will probably turn into two videos. We're going to start by designing the price adjuster class, and then we're going to tie it all together with the Bluebook class. And once this final feature is done, we'll be able to tie the entire application together with the model view controller. And so we're sort of on the final stretch here. Without further ado, let's go ahead and dive into our Notepad++ and begin to write the price adjuster class. You see here I have already a Java file called price adjuster. First thing we're going to do is, just like always, make sure that we include it in the correct package. And then this class is going to actually use one external library. We're going to need to manipulate the date, and we're going to need to calculate the age of the car, and in doing so we're going to use a date object. And so from the java.utility library, we're going to import an object called local date, like so. And then we'll go ahead and declare our class as being public, and it's a price adjuster class. And then in here, we're going to go ahead and, following the Singleton design pattern that we're already familiar with, we're going to provide the logic to do an instance of this class. So let's do a private static price adjuster object that we're going to call price adjuster, and we'll set it equal to a new instance of price adjuster, like so. And since this is private, it's not going to be accessible, so we're going to need to provide access to that. So let's go ahead and write our constructor method. The constructor will also be private. It's going to be a private constructor for price adjuster. And then we'll declare the public get instance, and this will be a static. It will return a price adjuster object, and we're going to call it get instance, like so. Now in this one, unlike the other Singleton design pattern methods that we've written, we're going to use something called that's going to be a little bit more active. And so we're going to check to see if there is already the price adjuster object in creation, and if so, it's going to be returned. Otherwise, we're going to create a new one. So this is a much more active way of writing the logic. The previous ways were what were referred to as being the lazy Singleton pattern design method. So in this one, we're going to do if price adjuster is not equal to null. That is to say, if it does exist, then we're just going to return price adjuster. Now, if it is, we're going to need to generate a new one. So let's return a new price adjuster, just like so. And that will be the get instance of our price adjuster object. Now, we're going to need to start with every attribute of the car, so we might as well go in order. So let's go ahead and start the calculations for the year. And so this will have several methods in it that will accept each individual attribute, perform the basic calculation on whatever price is passed through, and then return an adjusted price. And so almost all of these methods are going to return double values. So we'll do a public, it will return a double. We'll call this year price adjust. And it's going to accept whatever the year of the vehicle is and whatever the base price being passed through is. And then within this method, we're going to go ahead and declare a double that we'll call the adjustment. We'll set it equal to 0 because at this point we don't know what that's going to be. And then we'll take an integer called age, and we're going to set this equal to a method that we're going to write called calculate age, and that's the method that's going to use the local date object. We'll pass through the year, and then we'll do some basic if-then logic. So let's say if the age is less than or equal to 10, which is a reasonably aged car, then we're going to set the adjustment equal to whatever the price is times 0.05 times the age. And so for every year that the car is old, we're going to subtract 5% from the price. And that will be the adjustment that we make. Otherwise, if it's older than 10 years, that's kind of an older car, and so we're simply going to make a much more drastic adjustment. We're going to set the adjustment equal to 10% of the price of the base price of the car. So we're going to multiply the price times 0.9, and that will be the adjustment that we make. And then finally, we're going to take the price that we initially passed through, and we're going to subtract the adjustment. Following that, we're going to return the new price, like so. And so that is essentially the method that's going to calculate the price adjustment based on the age of the car. Now, we do need to write this method here called calculate age. So before we get too much further, let's go ahead and write the public int called calculate age. I suppose this could be a private method, because I don't think that we're going to need to call this directly from any other class. So yeah, let's go ahead and make this a private method, just to have good practice here. So we have a private method that's going to return an integer called calculate age, and it's going to accept the year of the vehicle. And this method is going to create a local date object, like so. We'll call it current date, and we're going to set it equal to a method of the local date object called now. So it's local date.now. And that object basically returns whatever date it is in this very instance. So the local date object that we're going to call current date is going to be equal to a return of whatever the local date object sees as being this moment in time. The integer that we're going to define is going to be called current year, because we really don't need anything more than the year. And we'll set that equal to the current date. And that object has in itself a method called getYear. And we're going to set an integer called age equal to the current year. You probably see where this is going, subtracting whatever the year of the vehicle was, plus 1, because the nature of cars is that they tend to make the model 1 year in advance of whatever year it is. So we'll set that age equal to the current age that the current year that it is minus the year of the car plus 1, and then we're going to return that age. And that is going to be the calculate age method that this year price adjust method is going to call. All right, so far we're able to make a subtle price adjustment based on the age of the vehicle. So we're doing good so far. The next feature of the vehicle is going to be the transmission. So let's write a method that performs some basic adjustment on that. So this will be public double. We'll call it transmission price adjust, just to keep it with convention. And this one's going to accept a string that is the vehicle transmission, and then also the base price. So now this method is going to do some case logic. So let's say that we use a switch statement, and based on whatever the vehicle transmission is, we're going to make some adjustments. So in the case that it's manual, we'll do something, and then we'll break. In the case that it is automatic, we'll make a different adjustment, and then we'll break. And then in the case that it is an electric vehicle, we will do some other method, or do some other logic, and then we will break. And then finally, at the end of the switch statement, we're going to return whatever the price was. So now, in the case of it being manual, let's do price subtract whatever the price was times 0.05. We'll give them a little bit of a discount, a 5% discount for it being a manual car. Even though I myself prefer manuals, I just think they're a lot more fun to drive. In the case that it's automatic, we're going to add a 5% of the price. And in the case that it's EV, this one's going to be a little bit nicer. We're going to add a little bit more. So in the case of it being EV, we're going to add 25%. And so any given vehicle that is going to be an electric vehicle is going to have a 25% heavier price tag. And so that's going to be just about it. I think that's going to be correct. So we have the manual, we're subtracting 5%. We have an automatic, we're going to add 5%. And in the case of it being electric vehicle, we're going to add 25%. That's our entire switch statement. And then we've adjusted the price, and then we're going to return that final adjustment. So this method looks good. All right, so we're kind of getting right through this. Let's go ahead and figure out the next feature of the vehicle, which I believe is going to be the drive. So we have three options here. Let's go ahead and write the public double, and it's going to be drive price adjust. And the drive is also in the format of a string, so we'll call that vehicle drive. And then we also need the base price. In this method, let's go ahead and define an adjustment variable. And it's going to be equal to the price times 0.15. So the adjustment is going to be equal to 15% of the price. And so what we're going to do is we're going to say, if it's front wheel drive, we're going to subtract 15%. If it's rear wheel drive, we're just going to leave it at the base price. And if it's an all wheel drive, we're going to add 15%. And so the rear wheel drive vehicles will have no adjustments made, but the front wheel drive will give them a little bit of a discount, and the all wheel drive, we will add a little bit of a price hike there. And so now, just like the previous method, we're going to use a switch statement because this is a case selector. We're going to accept the vehicle drive as the argument, and then we're going to define the cases. So in the case that it is front wheel drive, we will do something and then break. In the case that it is rear wheel drive, we will perform some logic and then break. And then finally, in the case that it is all wheel drive, we will have some different logic and then we will break from that. And that's going to be our entire switch statement. So now, just like we talked about, let's go ahead and take the price and subtract the adjustment. And in the case of rear wheel drive, we'll take no action at all. It's just going to be an empty case statement. And in the case of all wheel drive, we'll take the price and we will add the adjustment. All right, so this is looking pretty good so far, and that's going to be that entire switch statement. Let's go ahead and return price. And that method looks to be done. All right, so what is the next feature of the vehicle that we're going to need to calculate? So let's see. Let's take all of our safety features because we can group those all together into one method, and we can just do some basic conditional logic that says that some combination of these safety features is going to add or subtract from the value of the vehicle. So let's do a public double. We'll call this safety feature price adjust, like so. And it's going to accept the Boolean as to whether or not it has airbags, the Boolean as to whether or not it has ABS, the Boolean as to whether or not it has rear view camera, and then our initial price. Okay, so now in this method, let's define our adjustment. We'll set it equal to 0 because we don't know what it's going to be yet. And let's do some basic, maybe a little more complicated if-then logic. So if it has airbags and ABS and a rear view camera, let's make the price adjustment equal to 20% of the price. We're going to hike the price up by 20% if it has all three of the safety features. And else if it, let's see, let's define our parameters here. If it has airbags and ABS, or ABS and rear view camera, or airbags and rear view camera, then we will add 15%. And so this is going to be any combination of two of these features. So having airbags, ABS, or, I should make that an and, ABS and rear view camera, or airbags and rear view camera. So if it has two of these three features, we're going to add 15% of the total price. Next, we're going to do else if, and the parameters are going to be if it has only one of these features. So if it has airbags, or ABS, or rear view camera. Then we will simply add 10% to the price. And as you can probably imagine, if it doesn't have any of these safety features, we're just going to return the price without any adjustment. So it's going to be price times 0.1 to add 10%. And then finally, we're going to return the price plus the adjustment, like so. Okay, and so that's that method done. And one thing I want to point out is you probably noticed that in this case I used single ampersands and single bars right there. And this is effective insofar as we're working with something called bits, and this is a bitwise operator. And so this is basically saying that it's a little more complicated to do bitwise logic, but in this case it's going to work out for us, and it makes it a little bit simpler for working through three different features or any sort of pay-weight combination of these three different features. But the bitwise operators essentially say that if it's a 1 and a 1, then the result is going to be 1. If it's a 1 and a 0, then the result's going to be 0. And if it's a 0 and a 0, then the result's going to be 0. And that works with the and the or works equivalently with the or. So if it's a 1 or a 0, it's going to return a 1. If it's a 0 or a 1, it's going to return a 1. And if it's a 0 or a 0, it's going to return a 0. And so this is essentially what's going to do the logic here. And this is something that can definitely be talked more about because bitwise operations are used with a whole host of complicated programming. But for this one, it's a good way to kind of get exposure to it while keeping it simple at the same time. All right, so that's going to be everything that we need to define our safety features. So the next one we can, let's go ahead and work on the grades. So we'll do a public double called the grade price adjuster. Now's a good time to remind everyone that this complete code is available from a link to the GitHub, and so if this becomes tedious, feel free to just jump to the GitHub repository and just download it as is. It will be identical to what we're working with here. So we're going to do vehicle grade, which is in a string format, and then the initial price that we're going to need. And let's go ahead and start working on this one. So let's define our adjustment, and we'll set it equal to, we're going to set this equal to a price times 20%. So we're going to adjust it by 20% of the price. And then based on whatever grade the vehicle is, we're either going to subtract 20%, we're going to leave it as is, or we're going to add 20%. And if you remember correctly, the available grades were going to be economy, standard, and performance. So a perfect opportunity to use a switch statement. We will pass through the vehicle grade as our argument, and we will define the cases. And so the case is going to be economy, and we'll perform some logic and then break. Next is going to be standard, and we will break, and the final case is going to be performance and some logic, and then we will break. That's going to be our entire switch statement. So in the case of economy, let's go ahead and adjust the price by taking off that 20%, like so. The standard is going to have no adjustment, and then the performance is going to be the price adding the adjustment, like so. And after that, we will just simply return our final price, like that. Okay, and that takes care of the method for calculating the grade. Next, we will go ahead and write the method for calculating mileage. This is going to be a little bit more complex logic, not too bad. So it's going to be a public double. It's going to be mileage price adjuster. This is going to accept the mileage and then the year, because the miles per year are going to be whether or not this vehicle was overdriven, underdriven, or moderately driven. And then, of course, the price that we're going to need to adjust. So let's define our final adjustment, or our double adjustment is going to be equal to 0. Let's take our age and set that equal to calculate age, a method that we've already written in here, and we're going to pass to the year. So that'll give us the age of the car. And then we're going to do something called, let's call this mileage average. And it's going to be equal to the age of the car times 10,000. We're assuming that 10,000 miles a year is moderately driven. Anything more than that's going to be overdriven, and anything under that's going to be well driven, we'll call it, or underdriven, I guess, even though that kind of sounds like a pejorative. So we have a mileage average, which is going to be set equal to the age times 10,000. So a 10-year-old car could be driven 100,000 miles, and that would be a moderately driven vehicle. Then we'll define another integer that we'll call mileage overage, and we're going to set that equal to whatever the mileage is minus the mileage average, like so. And so anything overdriven is going to be a mileage overage. And then we'll do, let's do an if statement. So if the mileage overage is less than or equal to 1,000, so if it's only overdriven by 1,000 miles, and the mileage overage, actually did not do that right. So if the mileage overage is somewhere between 1,000 and 10,000, then we will have some sort of logic here. And I put an asterisk here instead of a parentheses. So let me get this right. If the overage of the vehicle that we've calculated is going to be between 1,000 and 10,000, then let's have an adjustment equal to the price of the vehicle times 0.1. We're going to take off 10% if the mileage overage is between 1,000 and 10,000. And then we don't need to use else because it's really only going to fall under one of these conditions. So then we'll do another if statement. If the mileage overage is between 10,000 and 30,000, that's going to be a much more overdriven car. Let's do an adjustment equal to the price times 15%. So it'll be times 0.15. And finally, if the mileage overage is over 30,000, that is a very overdriven car. We're going to take off 20% from the price. So we'll set the adjustment equal to the price times 0.2. And that will be the final adjustment there. Then we'll go ahead and make that adjustment. The price is going to be equal to whatever it was minus the adjustment we've made. And then we will return the price. All right, so that's the method that's going to calculate the price adjustment based on the miles of the car. Next, let's calculate based on previous owners. So, public double, previous owners, price adjust, and it's going to have an int that we're going to call previous owners, and the price that we're going to be adjusting. Now in this method, if previous owners is greater than 0, so if it has previous owners at all, then we're going to perform the calculation. Now if there are no previous owners, there's no adjustment to be made. So we'll return the price as it's passed in. But in the case that there are previous owners, let's define a double called adjustment. We'll set it equal to the price. And now here we're going to do a little bit more arithmetic. We're going to actually use some exponents. We're going to use some powers. And so what we're going to do is we're going to take the price, and we're going to make a call to an external library right here. I didn't want to do an import of the math library, but we only really need one single function from that. So what we're going to do is we're going to call the math library, and there is a power method from the math library that accepts two arguments. It's going to be the number, it's going to be the base number, and then the power that you want to raise that number to. So the first argument is going to be, bear with me here, this is a little complicated, but it's not too bad. 1 minus 0.7, and then we want to raise that to the power of however many previous owners there are. And so the more previous owners that a vehicle has, the greater that we should be taking off 30%. We're essentially taking off 30% because we're subtracting 0.7 from 1. So that will give us our 0.3, which is the price adjustment of 30%. And we're going to do that as many times as there were previous owners. And so the more previous owners there are, the more times we're going to subtract 30% from the price. And so, and again, this is tapping into the math library, the math object in Java, and using its power method, its power function, which accepts these two arguments. And so if we've done that correctly, then we can make the adjustment to the price. And if there are no previous owners, there is no adjustment. In either case, we're going to return the price. And that's the method for doing the previous owner's price adjustment. So now just a couple of more. Let's go ahead and calculate our safety features. So this is going to be another public double. Not safety features, luxury features. We already finished safety features. So we have luxury feature price adjust. And kind of like the safety features, we're going to have the booleans of keyless entry, the boolean of premium sound, the boolean of GPS navigation, and then the final price. And with all of those parameters, we can define our adjustment and set it equal to 0. Now, let's do the same conditional logic using bitwise operators that we did with the safety features. We're going to say if keyless entry and premium sound and GPS navigation, well, that has got quite a few luxury features. So let's go ahead and make an adjustment of 20%. Else, if keyless entry and premium sound, or premium sound and GPS navigation, or keyless entry and GPS navigation, so any combination of two of the three, then in that case, let's do an adjustment of 15%. And finally, if it only has one of those, keyless entry or premium sound or GPS navigation, well, it's not a very luxurious vehicle, but it has some. We'll make an adjustment of 10%. Like so. And if there are no luxury features, there is no adjustment to make, so we'll add the adjustment to the price, even if that adjustment happens to be 0, and we will return that price. Okay, nice and easy, and that's going to be how we write the method for the luxury feature calculator. So now, let's calculate based on accident history. So it's going to be a public double. We'll call this accident history price adjust. This one's going to accept whether or not it's been in an accident history. And then the price we're adjusting. And this will be fairly easy. Let's define our adjustment. Let's set it equal to 0. So if there is accident history, then let's just take off 15% right from the top. Doesn't really matter how many accidents. Once it's been in one accident, it's pretty much on sale at that point. So we'll take off 15%, and then we will adjust the price by that much, like so, and then we will return the price, whether or not it's had any adjustments. And so in the case of it not being an accident, then just the original price is going to be returned. It's going to have no adjustments. Okay, I think we're getting near the end here. The final method that we need to define is going to be the commission. And so whoever is selling this vehicle is going to want to make a little something on it. So let's do commission price adjust. And this is just going to be a pretty simple one. We're going to have the double that's going to be the commission because it is in a percentage form. So we'll take the original price being passed through. And then we're just going to return whatever the price is plus the commission percent. So it's going to be the price times the commission. All right. Looks like this method, or looks like this class is pretty much finished. We can go through and double check everything here, but as I said, it's not super complicated. It's just a little lengthy, and every method inside this class is going to be called by the Bluebook class itself, and it's going to be calculated, and that final calculation is then going to be returned to our controller class, which we'll write at some point. Just to keep this video a little less than super long, let's go ahead and write the Bluebook class in the next video. Otherwise, feel free to download the link to the entire project in the GitHub. Hopefully this was fun and entertaining and educational. Thank you so much for watching, and we'll see everyone back again shortly in the next video. Have a wonderful night.